Today we're going to be working with graphing rational functions, and this is going to be the worksheet that we're completing today. We're just going to do the first four, so 1, 2, 3, 4, and we're going to find the following. So we'll find your intercepts, your asymptotes, your holes, and then any additional points that we might need, and then we'll go ahead and graph. So let's take a look at this first one. When we go to graph these rational functions, we want to make sure that everything has been factored. So let's go ahead and put this all factored. The below has difference of squares, so x plus 1 and x minus 1. So now that everything is factored, we definitely want to take a look at if we have anything to cancel out. So when we go to cancel, it's not that we cancel these x's above and below. What we have to see is having parentheses that are the exact same. So in our case, we have nothing that will cancel. So we do not have a hole. We have no hole. We want to take a look next at your vertical asymptote. Your vertical asymptote appears in the denominator. If there's anything left over after simplification, then we would see that we'd have a vertical asymptote. So in our case, we're going to set x plus 1 equal to 0 and x minus 1 is equal to 0. And then we'll go ahead and try to solve for your x values here. So we'll come to find out that x is equal to -1 and x is equal to 1. These are where your vertical asymptotes are. Notice that it says x equals, x equals. We definitely want to see this because this will be a line, not a particular point. So it's going to be a vertical line at x is equal to -1 and +1. So let's now try and figure out your horizontal asymptote. Now your horizontal asymptote, we actually take a look at the beginning. We'll take out your leading terms. Your leading terms are important because they tell us a lot of information. So we'll pick out your leading terms. We have 2x over x squared here. And what we're really looking at is the degree. Now there's 3 cases. If the degrees, if your degrees match, so let's say this one was a 2 and this one was a 2, so they have the same degree, then your horizontal asymptote would be your leading coefficients. If they are bottom heavy, so more degree is down below, then we are looking at y equals 0. So we'll notice that here we are bottom heavy. Our degree down below is more than the degree above. Therefore, we have a horizontal asymptote at now y is equal to 0. Now, the third case is if it was top heavy. So let's say we had 2 here and a 1 down below. That just means that we will not have a horizontal asymptote. However, that does open the door to tell us that we could have a slant asymptote. That is only if the degree above and below are only off by 1. That is only when your degree of your numerator is 1 larger, exactly 1 larger than the degree down below. So for us, we have that bottom heavy case. So we have a horizontal asymptote at y is equal to 0. Now I want to find your x-intercepts. Your x-intercepts are going to come from your numerator here. So up above, we have your x-intercept. And we'll set that equal to 0. So we have 2x is equal to 0. Therefore, x is equal to 0. So we have the coordinate 0, 0 as your x-intercept. We also want to go ahead and find your y-intercept as well. Your y-intercept comes from us plugging in a 0 in for your x values. And that can be either from your original or your simplified. So we have 0 times 0 over here. So this zero's out up here, which means this whole thing will go to 0. Over here as well, we'll 0 everything out. Now you'll notice that when you do have the origin as your x-intercept, that'll also act as your y-intercept. So now that we have all of our special features, let's go ahead and actually give this a graph. And then if we do need additional points, we can certainly find additional points. Let me edit this just real quick. Put it up here. So first we want to plug in your asymptotes. So we have this over here, this over here. We have a horizontal asymptote right here. We also have your coordinate right here. Now, what we now have to figure out is, okay, well, we don't quite know your direction. So what we can do is go ahead and start to plug in points. So we can plug in some x values to figure out what is your y value doing. Now, typically we want to do this in your simplified form because it's a little bit easier to work with. However, you can do it in your original form if you prefer. I might actually go ahead and try my original. So 2x over x squared minus 1 here. Now, in order to figure out what your graph looks like, we want to plot 1 or 2 points to the left of your horizontal asymptote, 1 or 2 in between your asymptotes, and then 1 or 2 to the right of to the left of this asymptote. So let's start from the negative side. So we have x is equal to -1 here. So any number negative or smaller than -1. So maybe a -2, we can go ahead and plot that point. We want to figure out what quadrant are we going to be in. So we have -4 above over 4 minus 1. So we have -4 over 3. So we have the point -2 and -4 over 3. So that is just a little over -1. So we have -2 over here. So right here. Now we can kind of conclude where this graph is going to be going. It's going to be stretching up and down. But if we wanted to graph another negative point, you could always do -3. So f of -3 is equal to 2, -3. So get a -6 over here. -3 squared minus 1. So that's 9, that's 8. So again, that simplifies and we'll come over here. Oops. So our graph is going to stretch up and down like this. Now, let's take a look at maybe some positive numbers. So again, this being x is equal to -1 and this being x is equal to +1, we want to pick some numbers to the left, to the right of 1. So maybe 2 and 3 again. So this being now a +2 over 2 squared minus 1. So we have 4 over 3. So again, a little bit more than 1. And then we could do the same. Squared minus 1, 8. So this will be nice and symmetrical. So we can points right here. And now we need to figure out some points that are in the middle that we want to figure out, okay, is it going to be going down like this, or are we going to be going up? Or maybe we just kind of touch, excuse me, and go back down. Now this does require us to plug in a negative and positive intercept or fraction. So we're going to plug in, maybe let's do a +1/2. So f of +1/2 is equal to 2 times 1/2 over 1/2 squared minus 1. So we're at 1 over, let's see, 1/4 minus 4 over 4. So it looks like we are going to be negative. So we have -3 over 4, which means we have -4 over 3. So it does look like we are going to be coming down over here. And if we were to do the same with a now -1/2, so we have 2 times -1/2 over -1/2 squared minus 1. So we're at -1 over, and then we get 1 over 4 minus 4 over 4. So get -1 over -3 over 4. And those negatives cancel out. So we're now a +4 over 3. So we will end up crossing the asymptote. Now we can at times cross your asymptote, your horizontal asymptote, when it's sandwiched like this between your between two vertical asymptotes. So we can cross at times. Again, to test this, we just have to pick a couple points to see where in this direction is it going. And you'll see over here as well your answer key. So we do end up seeing that cross over here. And they found the same thing. They actually even went a step further and asked for domain and range and slant asymptote. Now, a slant asymptote, as we said, can occur only when your degree above is one more than the degree down below. So we will not have a slant asymptote. Now let's try it again with number 2. So this is number 2. So again, we want to make sure that before we find anything, we want to factor it. So you have 8 over x minus 3 and x plus 2. So that'll give us a -1 and a -6 when we multiply it out. So first thing we want to look for is a hole. Do we have any sort of hole? No, nothing ended up canceling, so we have no hole. Vertical asymptote, again, is coming from the down below. So vertical asymptote, let's see, at x is equal to +3 and x is equal to -2. Again, we find this by setting these equal to 0 and solving. So again, I can show that step right here. X minus 3 is equal to 0 and x plus 2 is equal to 0. So we do have two vertical asymptotes. Your horizontal asymptote, we are using your degree of your top and your bottom here. So we have 8 over, what was it, 2x? No, x squared. Now, if we wanted to see the degree on this, we could just say, okay, this is really x of x to the raised to the power of 0, which is going to be 1. So therefore, you can very clearly see that the below is going to be more, so we are bottom heavy. So we will have an a horizontal asymptote at y is equal to 0. Now, because it is bottom heavy, that just means that we have no slant asymptotes. Now let's go ahead and find your x-intercept. We look at your x-intercept from the above here. So we set the above equal to 0. So 8 is equal to 0 doesn't make sense. So that just means we will have no x-intercept. Let's take a look at your y-intercept. Your y-intercept, we go ahead and plug a 0 in for your x values, whether that is from the original right here or the simplified. If we did do it in the original, we're just plugging in a 0 here. So we get 8 over -6, or a 0 in for here. So -3 times a +2 will make that -6. So we have 8 over 6, which can reduce to 4 over 3. So we have the y-intercept of 0 or over 3, and that is a negative value. There we go. So I believe we found everything we needed to. Let's go ahead and graph this. All right, so we needed and let me move it over just a little bit. So we have your horizontal asymptote. We have 2 vertical asymptotes. Okay. We also have your y-intercept right here. And keep in mind, we do not have any x-intercepts. So that just means that most likely when we go to graph this particular value, we cannot be crossing this, this horizontal, your x-axis right here. So we can kind of conclude that your values here will have to continue downwards. Again, we can get a little bit higher if we wanted to plug in, well, actually, that's probably as high as it could go, but we could end up plugging in more values to figure out, okay, well, where does this thing actually turn around? But we can kind of conclude that this is the general shape of your function. Now, again, we have to figure out what other values to plot. So this being x is equal to -2 and x is equal to +3. We want to get 1 to 2 points on the left-hand side of this asymptote and 1 to 2 points on the right-hand side of this asymptote. So if we were to do that really quickly, again, you can put it either in your simplified or your unsimplified form. So your factored and simplified or your original. I'll do my factored one this time around. So let's see, a negative that's less than 2. So let's try -3. So f of -3 is equal to 8 over, let's see, that's -9, or sorry, -6. And that's -1. So we get 8 over -6. So -4/3. So -4/3. So we're going to be decreasing over here, here. If we wanted some more points to plug in, maybe we try a -4. Let's see, that is -7 times a -2. So 8 over, oh, hold on. Well, the double negative actually cancels, so that should be a positive. See, because that's negative, and that one came out negative. So we're actually a +4/3, so we're actually up here over +14. So we're over here. So we can kind of conclude that this will start to reach up here. And once you figure out what quadrant you're in, we're going to start to try and reach for these asymptotes. So you don't have to plug the second point in unless you definitely need a clearer picture. Let's go ahead and plug in 4. 8 over, let's see, that would be 1 times 6. So 8 over 6, a +4/3. I'm just going to check my signs one more time. Yeah. So that one's going to look like this. So again, trying to reach for that. All right, so this is what our graph should generally look like. And I'll show you the answer key for theirs as well. So you'll notice that we have that. So theirs goes up just a little bit higher. I think I had mine stop after this and kind of come down. But again, this is just a rough sketch. If we wanted to figure out more points as to where it turns around, we can start to plug in more values. Now let's do number 4. Nope, that's number 5. Let's see, number 4. There we go. All right. So let's see if you can pause the video and try these on your own. So first thing we want to do is factor. So the top gets to be x minus 3 and x minus 2. The bottom gets to be x minus 3 and x minus 1. Let's see, I'm going to just double check real quick. All right, now notice that we do have an item that cancels out. Now, anytime you cancel, you do create a hole. So we do have a hole on this one at x. So we take x minus 3, we set it equal to 0. So x is equal to 3 is the x coordinate of your hole. Now we need to figure out your y coordinate. Now to figure out your y coordinate, we want to plug it into your simplified function. So now that everything is canceled, the reason for that is if you were to plug this 3 back in, it zeroes out, and that's not what we need. So instead, we're going to plug it into your simplified form. So we get 1 over 2. So we have the whole at 3 1/2. Here we go. Let's take a look at your vertical asymptote. Your vertical asymptote is anything that's left over in the denominator. So vertical asymptote at x minus 1 is equal to 0. So at x is equal to +1 here. Your horizontal asymptote is coming from the degree the degrees of these two. So we have x squared over x squared. So we have the degree down below matching the degree above. So when they are the exact same, we take a look at their leading coefficients. Your leading coefficient here on both is equal to 1. So therefore, we have y is equal to 1. If this was 2 over 1 or maybe 3 over or 1 over 3, right? We're just taking your leading coefficient. So it would be y equals 2 or y equals 1 over 3, depending on your coefficients. So we also want to find your, just because they are the same, we do not have a slant asymptote. That is something that this worksheet says. So no slant asymptotes. We have an x-intercept. We want to look at your numerator from the above. So your x-intercept of the simplified form. So we get x minus 2 is equal to 0. So x is equal to 2. So 2 comma 0 is your x-intercept. Your y-intercept is when we plug in a 0 in your x. And again, that can be from your simplified from your original or your simplified. So if I plugged in a quick 0, we get negative 2 over negative 1, which is just a positive 2. So we get 0 comma 2. Now let's go ahead and plug that into our graph. So your graph I'll put over here. So let's go ahead and graph our special features. We have asymptotes. Let's see, we have, that one go? There we go. So this is at x is equal to 1. We have an x-intercept at 2 right here. We have a y-intercept at 0, 2, so up here. And because it already we've already plugged some of your valuable points in, we can actually go ahead and reach above and below. Now keep in mind, we do have a hole to plug in as well. So our hole is at 3 1/2. So that being right here, and I might need to thin that out just a little bit. So right here is the hole, and now we can connect your dots. When it gets to your hole, we're just going to jump right over. And again, and then we'll reach up and down. There you go. So that is the graph of this particular case. Now let's go to number 5, and I'm actually going to move this over here. Because number 5, we do end up having a slant asymptote, which is the first time we're actually talking about a slant asymptote. So I want to give us some space. So number 5 here. So I would ask that you pause the video and at least try to figure out some of your other special features once you factor and simplify. So for us, above and below, let's see, to factor this one, we have 2 and 9. So you get x plus 2 and x plus 9. And then down below, we still have 2x plus 1. So because nothing cancels, we can conclude that we do not have a hole. We want to take a look at your vertical asymptote, if we have one, that is from the denominator. So after it's been simplified. So in our case, your 2x plus 1 set equal to 0. We subtract the 1, divide by 2. So we have a vertical asymptote at x is equal to negative 1/2. Now your horizontal asymptote, we'll talk about here in a moment. Well, actually, we'll talk about here right now, actually. So we take x squared over 2x. Again, we take your degree of your numerator and the degree of the denominator, down here. And then we can look at them and see, okay, well, this is top heavy, right? So if it's top heavy, we do not have a horizontal asymptote. So we have no horizontal asymptote. So you can say none. But that does open the door for possibly having a slant asymptote. Now, before I get into a slant asymptote, let's try to find your other features, the one that we know how to graph. So x-intercepts. So your x-intercepts come from your numerator. So we're going to have two x-intercepts here. So we have x plus 2 is equal to 0 and x plus 9 is equal to 0. So we have two x-intercepts at 2, 0, or sorry, negative 2, 0 and negative 9, 0. Let's find your y-intercept here. We do this by setting x equal to 0. So looking at here, again, plugging in a 0 into your x values, we're left with 2 times 9, so that's 18 over 1, or we can zero out all of these. So again, 18 over 1. So very big y-intercept at 0 and 18. Now, let's take a look at your slant asymptote. Now, with your slant asymptote, we're going to use polynomial long division or synthetic division. For us, because this is a linear, we can try and go ahead and use synthetic division. However, it does get a little difficult because we will be working with a fraction. So if we prefer to do long division, which is probably what I'm going to show you guys here, it might be a little easier to work with that. So with long division, we have 2x plus 1 divided by, ours is, let's see, x squared plus 11x plus 18. So I'm going to erase the excess right over here. So when we go to divide, we take a look at your first leading terms here, and we're going to do monomial division. So we're left with x over 2. So x over 2 is what we're going to put up here, x over 2. And we're going to multiply this x over 2 by your polynomial on the outside. So we're left with x squared plus x over 2. Now we're going to put that into here. And what we're hoping for is that I'll actually do it this way, 1 over 2x. Our polynomials, we want them to end up your first leading terms to cancel. And we're going to subtract these. So we'll change your signs here and we'll end up canceling those out. Now we are left with positive 11x minus 1/2 x. So that's just say, okay, 11 minus 1/2. So that just means we need to change this to 22 over 2 minus 1 over 2 to get 21 over 2. So we get a 21x over 2, and then we'll drop our 18. So say plus 18. And then again, we're going to divide one more time. We can keep dividing until this x value is smaller than the one that we are dividing by. So we get 21 over 2x divided by 2x. So your x values are going to cancel here. That's nice. So now we're just looking at 21 over 2 divided by 2, or 2 over 1 if you prefer, and then we can do the keep, change, flip. So 21 over 4 is your response. So this is what's going to come up over here. We're dealing with a positive 21 over 4. And then from here, we get to multiply 2x plus 1 by 21 over 4. So we're left with, let's see, 21x over 2 plus 21 over 4. So 21 over 2x plus 21 over 4. And again, we're going to subtract these two. So we're going to change those. And it allows us to cancel over here. We're left with 18 minus 21 over 4. And that's going to be our fraction. And if we wanted, we could actually stop here because we don't actually need to continue any further, because this is actually your slant asymptote is the value from above. This is your quotient. So your quotient is the slant asymptote. Your remainder, your leftover bit, is just that. So our slant asymptote has the equation, and I'm going to put it in maybe this green color, or now this orangey color. Our slant asymptote is y equals x over 2 plus 21 over 4. So this is actually going to be a line for like your like graphing a line. So we are going to start at about 5.25. So about 5 1/4. And this is just your slope, right? 1 over 2. So let's go ahead and put some of these features onto your graph. All right, now let's go ahead and put in our special features on our graph. So we are going to map out your x-intercepts, or your asymptote here. So this is at x is equal to -1/2. We have your slant asymptote. So we're about 4 and 5 1/4. 1, 2, 3, 4, 5. There. We're going to go up 1 over 2, up 1 over 2. So we're kind of over here. We'll graph it like this. Best you can. And then I'm going to just poke some holes in it. Ooh. There we go. So that's our slant asymptote over here. Now let's go ahead and graph some of your special features. So you have -2, and let's see, that's 1, 2, 3, 4, 5, 6, 7, 8, 9 right here. You have your y-intercept, which I'm just going to pull all the way up here. Now we can go ahead and connect your dots. So this one, right, we're going to slant way up like that. And then again, we're going to pull up and over. So we should have a wonky looking graph such as this one. Again, if you need a better picture of it, all you have to do is start plugging in some points to get a better idea of where your graph is going to be going.